Hi everyone, welcome to my Abhyas. I am Jyoti Sandeep, your math teacher. In class 12th, we have completed one chapter. If you have missed that video, please go back and check. And today in this session, I am going to start the second chapter for class 12, that is inverse trigonometric function. In inverse trigonometric function, we have both the concepts, that is inverse function and trigonometric function. This is a combination of both inverse function and trigonometric function. I'll tell you how it is. And what is most important in this? Inverse function we all know. Where to have studied this inverse function? Function chapter. That was our class 1 first chapter, right? Class 12 first chapter we have studied that. Functions in that inverse function is already done. Trigonometric where you have studied? Class 11. Yes. Even before, like class 10th also you have studied trigonometric function, but actual trigonometry like a submultiple, multiple, all that comes in this class 11th trigonometry. Okay, now we are combining that inverse function and trigonometric function, but why we are doing that, why we need this inverse function, that I will explain you now. So what happens now, if you are taking only function, we are talking about trigonometric functions, so always I'll bring the trigonometric functions here to explain. Okay, suppose you are taking y is equal to sine x function. This is nothing but trigonometry and we are talking trigonometric function, so I'm taking y is equal to sine x as one function. If I take the graph of that, we all know how the graph will be for sine x, y-axis, x-axis and origin. So I am taking all the angles here. Few angles you take. In one rotation, 0 degree, 90 degree and 180 degree and 270 going back to 2 pi I am taking. So this completes one rotation, right? So here if I take, it will be minus pi by 2, minus pi and so on. So what is the maximum sine can take? What is the maximum value sine can take? 1 is a maximum value. Before that, if you see 30 degree, 45 degree, it will 45 is 1 by root 2, right? So that means it is less than 1. If you take 30 degree, it is 0.5. 0.5 is also less than 1. So it will go on like this. When you reach pi by 2, that will reach its maximum value. Okay? Maximum value. So sine will reach its maximum value when it comes to 90 degree. Okay? After that, it will go on reducing. And at pi by pi, sine pi, again it goes to 0. So here it will be minus 1, again it goes to 0. So what is happening? Maximum is 1 and minimum is minus 1. This is the peak of that and this is the depth of that. Okay. So we understood this much, 1 and minus 1 are the range of this sine function. Maximum and minimum for the sine function. But one thing you observe here, coming to inverse function now, here this is 0. Again the same thing is repeated here by the value. Sine 0 is 0, sine pi is 0 and sine 2 pi is also 0. So what is happening here? If I take function sine 0, sine pi, sine 2 pi and all multiples of pi if you take, all that value will go to one value, which is that 0. Sine 0, 0, sine pi 0, sine 2 pi 0, 3 pi, 4 pi and multiple of pi will also give you 0. Just see if you are reversing this. Suppose this is a set A, set B and this is a function what we are talking. Now I am reversing that and I am taking from set B to set A. What is this function called? Inverse function. So this is taken as a F inverse. When I am changing the direction from B to A, that becomes F inverse. So here what is there? Only 0. Here I have sine 0, sine pi and sine 2 pi. So if one element is going to multiple elements, will that be a function? See now. So to single element is going to 3 different elements in set B. So this is not at all a function. Correct? So why? When I am talking about F inverse, it has to be, this is a reason that I have already explained in inverse function, why we are taking 1, 1 and onto. This again I am telling because the chapter is like that. Okay. So if you are talking about F inverse, how the function has to be? The function has to be 1, 1 function and it has to be onto function. These two are very, very important to remember. When you are talking about F inverse, it has to be 1, 1 function and it has to be onto function. And this is the reason for that. So multiple mapping is coming. So if you are avoiding that, then you have to take 1, 1 function. This is one reason. And if you take here, if you are taking, so angle will differ, right? So if I am taking sine 0, it will come as a 0. If I am taking sine 30, it will be 1 by 2. What about the value which are in between? There are so many values between 0 and 0.5. Correct? Because how is the mapping? Mapping is from R to R. When the mapping is from R to R and codomain is R there. In R, we have all the numbers. Correct? Decimal also. So what about the decimal here? 0.2, 0.3. Straight away from 0 to 1.2 we have gone. So all the numbers are there, and here also we have so many angles. We have 1 degree, 2 degree and we have 5 degree. But chances are there for this real number not to be a part of that. Okay. Definitely few numbers are there who are not relating with the set A. That is the reason it is not a onto. So bring that as a 1, 1 and onto. What should I do? I have to restrict that. Correct? From that, the whole idea of inverse trigonometric function has arrived. Why it has to be 1, 1? Why it has to be onto? Because of F inverse. If it has to be F inverse, then it has to be 1, 1 and onto. That is why we have this restriction. That is why we have this something called domain and range here. Okay. So let's go back to the PPT and check what is this domain and range in the inverse trigonometric functions. First, I am talking about sine function, obviously. So inverse sine function, when I am seeing, see, this is the inverted. If you are seeing the proper graph, how it was, angles were here. Just now I wrote, correct? See here, angles are on x-axis, values are on y-axis. If I invert this, I rotate this, okay? I rotate it using this direction, anti-clockwise direction by 90 degrees. Then I will get sine inverse graph. The same graph. Here it is like this. If you want, I can put the graph here only. Maximum 1 and minimum -1 is the range. That is how sine graph will come. Maximum it will go and it will go to 0, it will reach -1 and here it will be 2 pi. So if you are rotating this, then you get this graph, and that is taken as y is equal to sine inverse x, y is equal to sine inverse x. Okay. Then what is the restriction for sine inverse? Why we are giving that restriction? We understood that. Why we are giving that? Yes. For this one, why we are giving the restriction means it has to be 1, 1 and onto. It has to be bijective. That is the reason why I am giving the restriction for sine inverse. Not only sine inverse, all the trigonometric function, one or the other restrictions are there, because then only I will get this inverse. Otherwise, I will not get that. Okay. So what is the restriction for this? Restriction is this. X value should lie between -1 and 1. When x value lies between -1 and 1, then y value lies between pi by 2 and -pi by 2. Got it? So what is the domain of this? Domain of sine inverse I am talking. Okay. Domain of sine inverse will be -1 to 1. That means I can give that. Domain is what I am giving. Range is what I am getting back. This is input. Okay, I am giving the input. Range will be output. If I am giving this minus 1 to 1 as an input, what I am getting, that is the range, that is minus pi by 2 to pi by 2. That is output. So this is the domain and range, and domain and range is very important. Not only it will come to 1 mark, on that only we are doing problems. Okay, so that is very important to remember. There is one table also, I will explain that after, cos inverse and tan inverse. Just quickly see the graph how it will be. Not in detail you have to go, but only thing you have to know here is this one. F is from 0 to pi to minus 1 to 1. So this becomes the domain part here. Okay, when you are talking about F, angle will be domain and range will be minus 1 to 1. So when you talk about F inverse, that is like this. So then domain becomes, because we are going ulta, right? So domain becomes minus 1 to 1 and range is 0 to pi. That is one interval what I am getting there as a range, and repeated values will be there if I take the other interval. So this is one interval where all the values are there and all different values I am getting. So this will be the domain and this will be the range for cos inverse. Okay, restrictions you have to remember properly. When you go to tan inverse, see, F is from minus pi by 2 to pi by 2. You are not taking close interval here. You are taking open interval because this is something which we don't know. Correct? That we know what is the value of tan pi by 2. Tan pi by 2 is not defined. Okay, tan pi by 2 is not defined. Tan minus pi by 2 also won't be defined. So we can go very near to that value. Pi by 2 and minus pi by 2 what we have taken, no? We can go very near to that value. We can't touch the line because we don't know what is that. When something is not defined, how you go on the line? Not possible. So just go near to that. That is the reason why I have open brackets here. Remember that. Tan always has an open bracket. Okay. Minus pi by 2 to pi by 2 will be F's domain and R is a F's range. Okay, codomain. If I am talking about tan inverse, then ulta you have to go. What will be the domain part? Domain part is R and range will be minus pi by 2 to pi by 2. Got it? This is the only difference in sine inverse and tan inverse is the bracket. There we have square bracket, here we have open bracket. I have told you the reason. I have asked you to remember also. Clear? Now see. After these three graphs, I am not discussing again cot inverse, secant inverse and cosecant inverse. So straight away this table. See, like this, if I go and explain the sine inverse, cos inverse, tan inverse and all, it is little confusing, right? How to remember each and everything has its own brackets, its own value. So I'll tell you one thing, how to remember. So big trick to remember this. Okay, if you listen to this properly, you will not forget till you complete your education in this class 12th. Okay, so what I'm doing here, we'll make a 2 groups. 6 trigonometric functions are there. 2 groups I am making, and in first group, sine inverse, tan inverse and cosecant inverse. Just assume that these 3 are best friends. Okay, everywhere they'll go together. And second group, what I am taking here is cos inverse, secant cot inverse and secant inverse. Can you remember this for me? Because I am telling you here the trick. So this much you have to remember. These 3 are in one group. They are best friends, and these other 3 cos inverse, cot inverse and secant inverse are a second group.